Can you hear me? Okay. So thank you for the introduction and thank you for the invitation. I know it was a long day and I tried to be quick and I had a lighter subject, so I hope my slides will be easier than and not as much technical as it used to be on this stage. So I chose Kaggle Kernels and I'm glad that Anthony mentioned them in the beginning. Because I think it's a useful way to learn new stuff, collaborate with people at Kaggle, and I really like the open community at Kaggle, and I'm glad that they are going into that direction. Obviously, machine learning competitions are still my favorite part of the game, but I like the discussions and kernels as well. And I selected three different topics. First, I will talk about Kaggle in general, because they have a nice data set about Kaggle, on Kaggle, so it's called MetaKaggle. Then I will talk a bit about my experience in the quick draw competition. And at the end, I will talk about the recent open-ended analytics competition, which was kind of a first at Kaggle, but it wasn't really the first. And I had a simple voting in a Slack channel previously, and you participated in it, and you selected each topic almost equally, so the difference isn't significant, so I tried to cover each. Let's start with the MetaKaggle part. So, and Jean-François said he doesn't like pretty charts and upvote begging. I'm guilty. I like pretty charts and I like to collect upvotes with kernels. So this is the journey of the popularity of kernels. You can see weekly upvote increasing trend. Of course, we have more users, we have more kernels, so it's pretty obvious that it's going up. The blue line is for the kernels. In July 2016, a new progression system was introduced for Kaggle. Now you have 3 pillars. You can collect points for competitions, for kernels, for discussions, whatever you like. And I would like to focus on the green chart as well, because you can see huge spikes in the discussion hot topics. And most of the time, it's usually when a competition ends and everyone is sharing their experience, but not only limited to that. So I selected a few peaks, and let's move from left to right in time. So here you can see two quite active stories. They are about leaks in 2 different competitions, and whenever leakage is found, I guess it's the best to share with the competitors and give them a possibility to use them, improve them, and if you know that there is a leak in the dataset, you can later still try to eliminate it and tell to the sponsor what would you achieve without knowing the leakage. And on the next, we have a higher bubble. It's the passenger screening challenge. So like in real life or in any other network, usually negative comments and sentiments are also there. It was a global challenge where only the US guys could collect prize money for legal reasons, and it was quite a heated topic. But we have positive stories as well. On the Kaggle survey in 2017, they asked the comment and feedback for which kind of questions should they ask. It was the most popular weekly topic at Kaggle. And the next, we have a baseline solution, Instacart. You could imagine it's a good thing because you have a baseline, but it was a very heated topic because someone posted not a kernel, but a link with a GitHub repository at the end of the week with a really good solution, and it disturbed the leaderboard, and people don't like when the leaderboard is disturbed. And at the end, we have 2 kernel stories, and both of them are a bit about issues with kernels in general, and the last one was even mentioning we should allow downvotes. I will get later to back that. And at the beginning, when the 3-pillar progression system was introduced in 2016, there was a fear that now it will be too easy to collect gold medals, bronze medals, silver medals, and grandmaster and master status with the different channels. But it turned out that even if it's easier, I guess, with kernels and discussions to get medals, the overall progression progression system is quite stable. We have thousands of masters, 1,000 masters roughly, and we have more than 100 grandmasters in the competition area, which is still the largest pillar for Kaggle. But we have only 5 grandmasters for discussion and kernels, and Jean-François is here for the discussion. I'm not sure if anyone from the kernel grandmasters are here, but I also would like to mention Hengcher Kang, because I'm pretty sure you should listen to what he says when he's competing, because he shares each and every idea he has, so you have to follow in competition discussions. And on the right, you have a small pictures which show you that not only the masters and grandmasters are collecting upvotes, actually even the Kaggle team, Dan, Rachel, and Megan, and Ben, likes to share mostly tutorials, and they also try to educate people. Here's just a small chart with the increasing cumulative upvotes, so you can collect points for kernels as well. SRK, I guess I won't pronounce his name. So he's the leader in kernels. He shares excellent material. I would like to highlight Shivam Bansal, maybe, because he's this pink line. He joined quite lately to Kaggle, and he managed to get Grandmaster status for kernels in like 6 months. In theory, it's easier than for competitions, but not a lot of people achieved it, so I guess it's also a significant achievement. And I had a few random kernels selected, just to highlight how different kernels could be. So in the first, you have a tutorial kernel from Pedro Marcellino. It's the most upvoted kernel. It has more than 3,000 upvotes, and it has more than 1 million views, which is pretty much in the kernel ecosystem. The second one is from a recent competition. William Cook and Professor Kelt Hersgone won the Christmas optimization problem this year. And you can use Python and R mainly for kernels, but they even managed to put their solution into the kernel environment, where they downloaded their C code, use a shell script to install it and compile it, and then run it. And they found a way to basically to put their solution into the Kaggle system. And I'm glad that they won that competition, because when the first Traveling Santa competition was introduced, I used their software to compete in them. Then we have Konstantin, and I guess Pavel and Konstantin won the Mercury competition. It was a special, not guess, I know that they did, and it was a special kernel-only competition, I guess one of the first competitions. I won't talk much about kernel-only competitions, but I see it's a nice and unique way, because everyone has the same computation power, and that's a good thing, I guess. And after the competition, they shared not the best solution they had, but pretty close to the best solution, and it contained only 70 or 80 lines of code, and did an amazing job to summarize their best model. So it wasn't the usual huge ensemble like you could end in a competition. And of course, heads or tails needs to be mentioned as well. He uses mostly R, which is not that common as the Python kernels nowadays. And he has 17 kernels, and each of them are gold. So whenever he shares something, he polishes it until it's perfect. And actually, he has the 5 longest kernels, and not only for line of code, but also for quality and for content. And the fifth is from Gilberto. It was just a 6-line kernel, which showed the pattern in the recent Santander value prediction challenge. And this pattern was a leakage. So I think discussions and kernels are also good to share strange patterns about the data. And the next slide will talk about that competition, because so far that was the good part, but also kernels could be dangerous as well. So let's focus on the black line right now. That's just the classic leaderboard progress in this competition. So you have error loss, it's root mean squared logarithmic loss. We already heard about it today. And you would like to decrease this error. And what happens is that after a few weeks, it suddenly drops. And when there is a significant difference on the leaderboard, on the top place, you know there is something fishy going on with the data, and you start finding it. Someone posts it when they find it, and then suddenly people are getting way better methods to exploit it. And at the end, it settles now that everyone knows what is the leakage. You still have to build your ensembles and your optimization, and finally you have to win the competition. But on the blue line, you can actually, from the meta Kaggle dataset, you can access the submission scores during the competitions, and you can check what was the best kernel submitted by time. And these are private kernels, so they are not necessarily public kernels. But of course, in smaller problems, there is a large chance that if someone posts a high quality and high performing kernel, then it could disturb the competition, and it could destroy in some way many people's experience, and it could be a dangerous thing, so be careful. And there are less problems, or not as important problems. I really like this meme. It's from Peter Herford. And from milder scenes, you can go to heresy. So when you like a kernel but doesn't upvote, it's forgivable. But I'm also not very fan of blending of blends and averaging each other's kernels and diluting the kernels with not that much learning experience, but just tiny improvements on the public leaderboard, which might or might not favor you at the end when the private leaderboard reveals. And also forking and upvoting and taking no credit for kernels, it's some kind of a problem, but I don't consider as serious as the slide before. So that's why the forum started to ask for downvotes for kernels. I generally don't believe downvotes would be a good way even for discussions. So just when you feel that your work has been stolen, just comment it below the kernel, and I guess the problem solved. And on the right, you can see lots of geese. As it turned out that for some reason, people like to fraud in kernels as well. So there was a competition where popularity was rewarded, and suddenly a kernel increased votes quite a lot, and each of the newcomer votes were registered in that day, and it's also a minor problem. I don't think it would break the platform, but I just wanted to mention that. And my last slide about the kernels, and it's more about the community. So I liked network theory. As my first degree, I was studying mathematics at the university, and my thesis was about network theory. And here you can see the largest component when each vertices represents a Kaggle player, and the edges are based on whether they teamed or not, at least in one competition. And there is a nice theory, let me check. Okay, there is a nice theory. So lots of Hungarian guys were good in combinatorics and graph theory, and Erdős and Rényi had a simple model where each edge has an equal probability to be represented in a graph. And there is a nice theorem that shows the largest giant component. If you have enough edges, it's much larger than any other components in the graph, and it proves this. You can check and verify it for this Kaggle network as well, even though this simple theory usually doesn't work for social networks, because if you see the middle area, it's a force-directed layer. So Gilberto is probably between some, not probably, I checked, and I will share it later. He is somewhere there. He had more than 80 team members during the game. So obviously, if you are in the top of the global leaderboard, you have better chances to team up with people. And I will go to my next topic. So there was the quick draw doodle recognition. Anthony mentioned this competition as well. And I started to compete in this one because I am still learning about machine learning and mostly deep learning, so I don't have as much working experience in this field, but I like to try a new thing, and that's why I still use Kaggle for a good excuse to try out new things. And it was another good example of gamification. Google AI team collected billions of drawings with a simple app where you were asked to draw something like an owl, and as you draw it on the phone or with your mouse on your desktop, the stroke was recorded in time, and later with 50 million drawings were shared in this competition for more than 340 categories. And I won't talk about how to win this competition because Pavel and Pavel, I guess, already did. They aced this competition by a good trick at the end and by good labor. We participated with Boyan and ended it in the bronze section, but it was a good learning challenge. I wanted to share more about kernels during the way. And if you think about, you have 50 million drawings and 300 categories, in the beginning I thought it would be a challenging task for a computer, and especially if you are limited to the Kaggle environment. But recently the computational limits, thanks to the Google merge, I guess, increased, and right now you have 9 hours computing time for kernels. You can use GPU, not the most powerful one. NVIDIA Tesla K80 is quite a cheap GPU if you rent it from cloud provider, but for example, I don't have a GPU at home, so it's even the CPU or the GPU machine is better than my desktop at home, and it's a pretty good environment to test ideas and post baseline submissions. You can chain kernels, so you can train the model, save the result, and forward it, and one competitor actually did. He also didn't have access to GPU, and he used the Kaggle platform system for quite a good amount of time, and he made it to the top 10 at that time. You can have network access, and also it's much more flexible than it used to be. And during the competition, I shared a baseline solution or a different kernel which supported it and shuffled the original CSV files to be more consumable in the kernel environment. I shared a simple joke, basically how to draw an owl if you know the name, and also similar visualization kernels. And I like to work on these problems because as I guess Darius mentioned, the time management issue, if you want to keep up and fight for the top leaderboard places, that could be very demanding, and I find when I have a few days or just a week for a competition, I find it better to learn something new and then at the end summarize it in a kernel and share it with the community. And this is just a simple version of my end-to-end kernel solution. So it used 9-hour computation limit with the simple GPU. It sampled and shuffled the original data set. Each image was, or each drawing was transformed to grayscale images when the time of the drawing was basically the color coding. And a nice image generator, a simple Keras MobileNet version was shown. So it was a really example tutorial code, but at that time it was the, and still at the end of the competition, it was basically the best public kernel available to this problem. And of course, it's hard to choose the right architecture, and I don't know how to choose it. I know that what the winners usually do, they choose each and every different architecture and blend it, and I don't have the time to do that. But here's a nice benchmark analysis recently published, or soon it will be published, paper, where you can compare each different architectures on the ImageNet data set. Of course, in real life, you might have a different problem, but at least you have an idea the computation times. And you can see the mobile net here, which is basically designed to be fast. And it was good enough for this kernel experiment. And that's a PDF, and it is a GIF, so it's showing basically how the drawings are collected. So as I mentioned, you have the strokes as the user draws it. So we have actually a time series data, and you can take this problem into two directions. You can look at the image at the end of the drawing, and that was the previous approach, so you can apply CNNs from there. Or you can use recurrent neural networks on the time series or the strokes directly. And in the kernel environment, there are also good examples if you are interested in LSTMs or baseline tutorials. At the end, CNNs were more powerful, as the first team mentioned. And in the end, I would like to conclude with my third topic. I really like that Kaggle has, beside the classic supervised machine learning problems, now have open-ended analytics competitions as well. And the NFL punt analytics competition wasn't the first time, so if you looked at the data science for good competitions, they weren't listed as the competitions, but you could find them on the dataset page. And usually they do they try to do something good. In this example, Kiva crowdfunding is a global crowdfunding service. It's basically a non-profit organization and tries to help small businesses around the world. And the task was not to minimize the root mean squared error, but to try to find a different way to assess poverty level with the available data they have, or collect more data. So I like these open-ended challenges as well. Of course, there is a bit problem how to evaluate these challenges. At the end, you have judges. That's the most common way, which is subjective. But the other way is also to based on upvotes or popularity, doesn't guarantee success. The second one was the recently closed Kaggle survey challenge, where Kaggle collected survey and they put small prizes to analyze small subsets of the data. They had a good collaboration in both competitions, and lots of interesting kernels and ideas can be found for these data sets. And I would like to talk a bit about the punt analytics competition, because it was just a quick turnaround, one month competition from December to January, so it also involved Christmas and the New Year. Not a lot of teams managed to participate in that, and it was quite unique. So not even a traditional open-ended competition, I guess. The goal was quite narrow, so it's about American football. So I have to stop here a bit because I don't have a slide to explain the game. And in Hungary, soccer or European football is way more popular than any other sports, and I think way more popular than it should be. But American football is from the very far point is similar. You have 22 players, they are chasing the ball, and the competition had to focus on a small subset of the game, which is called punt. And in American football, you have a long field. You have to go forward and forward to accomplish 100 yards. And at the end, if you score, that's a touchdown or a field goal, you get points. And punt happens when you can't go forward. So you have 4 attempts to make 10 yards repeatedly, and that's how you get to advance through the field. And at the end of your turn, when you have used all your possible attempts, you have to kick the ball to the opponent team, and that is the punt event. And it's usually quite dangerous because when the opponent catches the ball on the far away on the other part of the field, each team starts to run together and lots of collisions happens and lots of concussions happens. And the rule of, or the goal of the competition was to reduce the concussions during punt plays. So it's a very specific and narrow part of the game, and you had to propose rule changes in order to do that. And they required summary slides, which is kind of new, so you have to upload a PDF or a PowerPoint presentation, and you had to make sure that your analysis and all your calculations are reproducible, and you had to share kernels. And the objective was solution efficacy, which was basically testing how useful would your solution be in terms of reducing the concussions. So is the change significant enough to make the game safer? And game integrity was also key, so the game shouldn't be less interesting or shouldn't change too much. And 4 teams were selected into a pitch-off event, and they will present their solutions in Atlanta in the next week before the Super Bowl. And unfortunately, we weren't selected, but we learned a lot. And here is a good example that why popularity wouldn't be a good measure for such a competition. I just chose 2 of my kernels. So there is a word cloud in the app. It collected 37 upvotes, and our total summary report based on 1 month's data analysis collected 28 upvotes from the other competitors. Of course, it's quite tricky to ask upvotes when you are competing against each other, and it's counterproductive. But a word cloud is nice, but doesn't help NFL to reduce concussions. And I had a good opportunity here to team up with one of my friends. We met in high school. We were 12 years old, and it was 20 years ago, so we are long-term friends. And actually, he's a huge NFL fan, so basically he had the domain knowledge. And I like Kaggle and kernels and data analytics, so we were a unique match. But he also works in communication and consulting in a bank, so he knew how to prepare great slides, and that was our secret weapon. And if you want, you could check later our summary kernels, but I just wanted to show some of the resulted slides at the end. I won't go into too much details because probably you're not as interested in American football as us or the other participants in the competition, but I just wanted to show that concussions are increasing, and yeah, the punts could be awesome and dangerous as well. And this is a nice story we found. Actually, very few positive samples or concussions happened. We got data for 2 seasons, which is more than 6,000 different punt plays, but only 37 recorded concussions happened. So you have a limited subset. And some teams find that the left gunners, which is a position on the field, they are attacking the punt returner, whatever. So the left side of the field was 4 times as dangerous as the right side of the field, which would be a strange result if you could prove it by data. But obviously in statistics, 4 isn't really more than 1, especially if the result is insignificant. And we wanted to highlight that with this limited data set, you could have wrong conclusions. So this would be, again, another GIF. So basically, we also got 36 or 37 injury videos. You could play them again and again. We watched them by frame. It was even hard to identify the exact time when the injury happened. And what we were most proud of, that we managed to collect more data. And actually, we found data set on Kaggle already uploaded, because NFL is a huge sport, and with all the fantasy football and the betting, people like to collect and share public statistics. And we were able to collect more than 400,000 different play descriptions, which was useful to understand the overall game integrity. We read a few medical papers, and that's what I like in Kaggle competitions as well, that usually, even if you don't have the domain knowledge, you can get on the field or on the running, even for astronomical competitions, some domain knowledge, which isn't as much as a professional or PhD student would have in the subject, but it's most of the time it's enough. And yeah, they are quite fast and quite strong. And this is the slide about our methodology. We collected lots of additional data and calculated important features from the original data set, because it was quite nice that they shared each player's movement data. So during these punt plays, we know exactly for each second, or actually for 100 millisecond frequency, that where is the player on the field. We could calculate velocities and acceleration, decelerations, and we could identify collisions from the data set. But we also collected more data from overall statistics, and we had to understand the rules. The current rules aren't that easy for the American football as well. And we even had a chance to consult with coaches, with the Budapest Wolves. I'm not sure you heard about, but they are the Hungarian champions, and they defeated the Nyíregyháza Tigers, so they are a pretty good team. And we identified 4 main risk areas. The collisions, the penalties, and injuries, concussions were pretty most the focus of our analysis. And if you categorize the punt plays, you can have different outcomes after a punt. So when they kick the ball and the player catches it and stops it immediately, and even has a signal waving with his hand that he doesn't want to move with the ball, that's the safest part, because then the teams stop as well. There are rules protecting the fair catcher player. But if a return is attempted, and both the teams are running each other at full speed, that's when usually the dangerous injuries and concussions happen. And also there are some other smaller outcomes when the ball goes outside, or on the side, or at the end of the field, or the play is reverted, and such stuff. And we collected a few each and every dangerous statistics, and we found that obviously the return event is much more, 9 times more dangerous from many aspects as we could collect as the other ones, and as we suggested to instead of penalizing additional blocking or tackling behavior, it would be a nice effect to reward by the game the safest choice. So we had suggested to reward any fair catch, which is the safest part of the game, with 5-yard advantage to the receiving team. And we also checked game integrity, so we checked how much it depends if you end your punt reason in different part of the field. So we found that in the beginning of the field, so if you have to manage 100 or 90 or 80 yards in the next drive, that usually affects your expected points by 0.3 points. And in American football, the game easily ends up above 40 points, so it's not a huge difference. Especially that returns aren't that common in the game. They have 2 returns in each game. So we estimated the overall point effect is being negligible, below 1 point. And we checked a few risks, and we also suggested to we need more data. And actually NFL collects way much more data, but obviously for a small quick analytics competition, they didn't share all what they have in the competition. And that was my final slide. So I shared 3 different topics, and I also shared our solutions. I will upload the slides later, and you can check the links and all the kernels. And my main message would be to read and write more kernels if it's possible for you. Thank you.